Hello and welcome to our series of Understanding Rust from Basic to Advanced. I am PRK Jr., and together we will walk into the worlds of the Rust programming language. In today's video we will learn how functions in Rust works. Functions are prevalent in Rust code. You've already seen one of the most important functions in the language, the main function, which is the entry point of many programs. You've also seen the fn keyword, which allows you to declare new functions. Rust code uses snake case as the conventional style for function and variable names, in which all letters are lowercase and underscores separate words. Here's a program that contains an example function definition. We define a function in Rust by entering fn followed by a function name and a set of parentheses. The curly brackets tell the compiler where the function body begins and ends. We can call any function we've defined by entering its name followed by a set of parentheses. Because some function is defined in the program, it can be called from inside the main function. Note that we defined some function after the main function in the source code. We could have defined it before as well. Rust doesn't care where you define your functions, only that they're defined somewhere in a scope that can be seen by the caller. The order in which we call functions in Rust matters a lot. We can make a function asynchronous just by adding the keyword async in front of it. But in order for a synchronous function to execute, we need some sort of executor or runtime. This lets us await on the function. Without it, the function does not even execute. We can define functions to have parameters, which are special variables that are part of a function's signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversation, people tend to use the words parameter and argument interchangeably for either the variables in a function's definition, or the concrete values passed in when you call a function. The declaration of some function has one parameter named some number. The type of x is specified as i32. When we pass 100 into some function, the print line macro puts 100 where the pair of curly brackets containing some number was in the format string. Functions can return values to the code that calls them. We don't name return values, but we must declare their type after an arrow, dash. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of a function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. Here's an example of a function that returns a value. There are no function calls, macros, or even let statements in the function return 5 function, just the number 5 by itself. That's a perfectly valid function in Rust. Note that the function's return type is specified too, as -i32. Rust foundations are clear about safety. It is done to ensure your application works as expected. Notice how you return i32 from function 5 return function, and it is not accepted by our variable, even though our variable can have the same value. It is because Rust does not want to assume things for you all the time. It wants you to be explicit about what you mean. But sometimes, we need to parse between data types. For instance, if you are asking standard input to read from the terminal, it will read the value as an string. And then we need to check if our value be parsed to the data type we want or not. This parsing can only occur if our data type implements from trait, and that returns a result type. We will learn about traits and result types in future video. For now we can play along with try into, which lets us use from trait. Notice, when you return u32 from a function and you actually want to store it in u32. Now, over our try-into function, Rust Analyzer suggests us it can be result of U32 or infallible. Because infallible has no variance, a value of this type can never exist. It is used only to satisfy trait signatures that expect an error type, and signals to both the compiler and the user that the error case is impossible. That's it for today. We will gradually move towards more advanced topic in future videos. If you haven't already, don't forget to like, share and subscribe. Thank you and visit again. Happy coding!